Welcome everybody, my name is Yannick and today we'll be looking at the application that I've built utilizing OpenAI and langchain functions, or OpenAI functions actually, in the langchain framework to call those OpenAI functions and get structured data out of unstructured data. This application will eventually have a small web API front end to show you the data that we got back. And moreover, we're using the GPT 3.5 model for this function calling. But later, I will be diving into the application that I've built. First off, I want to explain a few things about function calling and why we want to utilize it. Function calling is a useful way to get structured output from an LLM for a wide range of purposes. By providing schemas for functions, the LLM will choose one and attempt to output the response matching that schema. And a schema is basically what we see here. This is a schema that we can give to the LLM to eventually get structured data back like this. Though the name implies that the LLM is actually running code and calling a function, that is not actually true. It's not completely true, no. It's more accurate to say that the LLM is populating parameters that match the schema for the arguments. So a function call is not really calling a function. It's more hypothetical function, I would say, because you're just giving a schema to the model you're using, and then with that schema, it gets back structured data with an input. So it's not really calling a function, but I would say it's a hypothetical function that you're calling. So why do we want to use function calling with web scraping? Well, LLMs are optimized to receive unstructured data in the form of conversational natural language, like a piece of text that you can scrape from any website you want. Let's say you want to scrape this website, or you want to scrape another website. You get unstructured data back from that website. This unstructured data is then structured by an LLM using a schema, and then it's processed and subsequently unstructured again in the form of natural language outputs. Langchain function calling in the context of web scraping facilitates a structured, efficient and integrated approach towards data gathering, processing and application development, especially in scenarios involving LLMs. I believe it's only in scenarios involving LLMs even. So the application we will be building utilizes OpenAI, an OpenAI model. So you need to have an API key if you want to join and code along with me. We're going to be building the application from scratch, and I'm going to be using two Python files to run this. First off, I'm going to be building out the web scraper, and I will see you when I'm done with this. So first, I've built out this web scraper Python file that is going to be opening a Chromium browser using Playwright. And then using Beautiful Soup, it's going to clean up a little bit of the data that we extracted from the browser, from a page that we want to scrape. And then eventually we are going to return a content, which is a simple string, a literal string. I've broken this down into multiple functions, and it's async await, so we can utilize more threads on our CPU. As well as utilizing a Chromium headless browser and scraping the websites using Beautiful Soup. You can check this out in the link in the description if you want to dive deeper into this, but it's not that difficult to understand. It's not yet utilizing any LLM. It's just scraping a website that we want, and then converting the HTML, the raw HTML, into a little bit of a more structured content string without, for example, the script tags or the style tags or any blank spaces that we clean here. And then giving that back to our main function that we're now going to be building out. So first off, I will need a OpenAI key. And an OpenAI key you can get from this website. You can click here to generate a new key. and then you put that key in a .env file. You probably know this already, but I will quickly show you how you will do that. You get your OpenAI key, this one. Oh, and then you put that in here, and you generate a key here, and you put that inside of the string. And then your main function you call with getEnv function your keys, and then you eventually put this key inside of the LLM to keep tab on all of your API requests. And next to that, we're using this schema, this JSON formatted schema, as a function call, so we can structure or unstructured data that we get back from our web scraper eventually, this content, this large string of content. I will show you how this content looks and how it converts this content with a schema and an LLM to structured data later. So I will be now building out the main functionality. I will see you later. So inside of our main function, this is the place that we call our web scraper that we just wrote inside of this web scraper. And then we're using the site data to extract, to use as an create extraction chain, where we also put in the schema that we just created and utilizing the OpenAI LLM with GPT 3.5. And here's as well the place that you put your OpenAI key if you didn't know that. So eventually we get some result back that is hopefully structured. But first, before we do that, I just want to create a quick git ignore. Never forget that. And in your git ignore, you put the .env. Needed to install that. Creating a virtual environment so our packages don't conflict with each other. Okay, I activated my virtual environments, then I just freeze the requirements.txt. Okay, I finally installed the latest packages, and then we are going to run the program, and I will get back to you with the data. And the data will be first printed what the site gives me back. This is the web scraping port that we get back, just the content. And then I will also be printing the results that we get back from the LLM. Oh, and we get some sort of, please add an environment variable, OpenAI. Oh, I didn't do that yet. So let me do that real quick. So boom, after we run the program, we get back this. Let's first say we're scraping the website EA Combinator, which gives back this content from the website. Hacker news, new, past, comments, blah, blah, blah. And eventually some posts. This is a post. This is the link to the post. This is the amount of points. This is the author. And this is the amount of comments. And this is another post. This is unstructured data still. And we're utilizing the schema now to eventually get this unstructured data into structured data. So we pass in the schema and the LLM to the create extraction chain from langchain. And then we get back this structured data. Name in search of the latest viewed article, Wikipedia. Points, 2017. Comments, 134. URL, this URL. And then the other JSON object is this. And then eventually you get structured data back. And now this is great. This is exactly what I want. And with this schema, I thought OpenAI to get me a name, some points, comments, URLs, and if they're required or not. So sometimes a URL will probably be not found. So that is the reason you don't put the URL in the required section. So that's the way of utilizing a schema to get structured data back. But a schema does have some disadvantages. Another solution that you might want to utilize and that we're going to be implementing is a Pydantic class. And why do we want to use that? Well, using a Pydantic class over a JSON object can offer several advantages when working with the data in Python. You have a base model, and that Pydantic class you can be more explicit in the data types that you want to use. And this can be essentially beneficial in applications that handle data from various sources, when ensuring consistency and correctness of the data is crucial. In contrast, JSON objects don't have a built-in mechanism of validating or type enforcement. You don't have any type enforcement here. Which eventually could lead to potential issues when processing the data. So this is structured, but still not type safe. And if we want to go to a type-safe solution, we can use Pydantic classes, which I'm going to be building out next. So let's get this out of the way. So Pydantic classes are type-safe. You can also use some IDE support to get back the right fields that you want to use. So let's call this a record website with a base model that we need to probably, I've already implemented this base model. This is a library, by the way. Then we're going to be utilizing the same fields as in the JSON object. So we'll be typing that out now. So here I have implemented the record website. We have given a description of the name that we want to extract from the unstructured data. And you can also give back a example of a name that might, a post might be. So what's new in Python might be a post. So we give them an example so it can use that to be more precise. So we now don't want to use this schema. We rather want to use a Pydantic scheme, Pydantic chain schema. So first let's make this Pydantic. Am I doing that correctly? No, I need create extraction chain Pydantic. Oh, I need to import that. Okay, after importing, we can check what we need. We need a Pydantic schema that's set to this class that we just built. And then we need an LLM, which is LLM, because we're utilizing openai LLM. I will be cleaning this up a little bit. I will make it run directly and get back a result. And that result I will be processing in a list comprehension, because the data we get back is a bit different. And I'm going to clean it up. So I'm going to have a dictionary, and in the item, I will call it item in dic, or item in results. If item in results, typing is difficult today, and we will be printing that out, and then eventually returning for the next function. So if we do this and we keep a note of this structured data, it will eventually be the same. So let's run, and I will see you back then when it's done. Okay, so I run the program again, and this is what we get back. As you can see, it's completely the same as the first JSON we got back. For small applications, it doesn't really matter, I feel like, but for larger applications where you want to really be sure you have the exact correct data type, Pydantic is the better option. But if you want to play around with it, I would say just use the JSON object. It's a bit easier to first get started with. So now we get this structured data back. What we want to do is we want to use this data and visualize it on a web page. Alright, I've finished building out our web application using Flask. Flask is a simple web framework you can use to create some endpoints and create a template for HTML where your data can be stored into and just visualize it. So what I did was I imported Flask and started the app. And then I have a app route to the root that gets me my main function running. and eventually get this response back. I will print this response really quickly, but more importantly, I will return this rendered template string that has the response and the template, this template, and then eventually it creates a minimal HTML page that walks through all the items in the response sticks and shows it on the web page. So how does this look like? Well, after running the application, I'm giving a link, this link, and I click it, and then I'm redirected to this page, this local environment that I've created. And then eventually, when my data loads, so when OpenAI is done converting my schema plus my content that of the website I scraped, I get back the results and the page will load. Hopefully, if everything worked fine. So essentially what we did was we first created a web scraper using Beautiful Soup and Playwright. Then eventually we started building out our Pydantic class or JSON object for what you want to use. And then using the create extraction chain with the LLM and the Pydantic schema or the other schema, scraping with the scraped website, so you can essentially get back the structured data. The structured data will be sent to our template and then rendered, which gives back this beautiful website, which loads right now, please. We got back an error. I will try to fix this. So I finally figured out what went wrong. It was the comments section that sometimes had no comments. That was a required field in my schema, so it broke. And this is the important thing about having the correct schema, because when you have a field that's required and that field is not used, as you can see here, some posts don't have comments, because you can see here this post has 87 comments and this one has just a hide, so it didn't know what to put there, because I have also explicitly told it needs to be an integer and it can't make some integer from hide. So what we need to do is make this an optional integer, optional int, and we can use the library from Py. Which one did I use? I want to use the typing one. I feel like that's correct. And then instead of these points, I need to put in none. And then we rerun the program and hopefully... And boom! This is what we get back. It did take a while, but eventually from this structured data, that is a simple list of JSON objects, we get back this result. We have a name, Hacker News, or the 10-year anniversary of the healthcare.gov rescue. Let's get to Hacker News and check it out. They can and will ruin everything. They can... Oh, I didn't get that one. Oh, the 10-year anniversary. In search... Oh, this probably just came on. No, there's 99 upvotes. That's weird. But yeah, we get the points back, which is correct, but it just got 4 more upvotes in the meantime, and we get back the comments, 68. It has 4 more comments back already, but hey, okay. And the link to the website. So yeah, that's it. And like I said, the reason it got stuck sometimes is because of this none with the comments. So now you just got to display none. So I've thought some more about this technique, and I've come up with some ideas that might be interesting to you of building an application that is based on this approach. Some examples include a automated market analysis platform. Here I've written them down. Create a platform that automatically scrapes financial news, market data, and analysis analyst report and provide real-time market analysis and insights. This isn't too hard to build right now, utilizing just a few lines of code, some web scraper, and openai function calling. Or a competitor monitoring system. Develop a system that continuously monitors competitors. Maybe you have some pipeline running every night that scrapes some websites and then essentially utilizes openai to get structured data back, and then you can monitor your competitors on websites, maybe press releases, social media you can check if that's legal. I don't know. Some stuff, some web scraping stuff you need to know is illegal, so I'm not responsible. You didn't learn it here. And another one is automated supply chain monitoring. Build a system that continuously monitors global supply chain information by scraping data from logistics providers, governmental trade databases, and news outlets. And this might sound really complicated, but it isn't. This is easily buildable with just a few lines of Python code. And I would say start building today. Start doing something at least with openai, because I feel like it's the future. We're going to be utilizing LLMs, AI, everywhere in our applications. We are going to be building them. So utilizing this technique will greatly improve your skills as a programmer, and I think this is the future. So make sure to play around with this stuff, and I will put all the code that I've here developed with the requirements file so you can play around with it in my GitHub below. So check that out, and I will see you later. Bye bye.